Take a moment to read Unit 6, Problem 7.2, Clock Coordinates. In this activity, students are to learn to use the unit circle to determine the coordinates on circles of different sizes. Students will focus on the location of the end of the minute hand relative to the clock's center. Students should make connections between the three clock sizes and their solutions. Students can give exact values using sine and cosine, or an approximate value based on the unit circle display. In a previous lesson, students have developed a unit circle. Their unit circle should have these approximate values that are on these tables listed for each of the angle measures in radians. We're going to use this unit circle and these approximate coordinates to help us answer our question. The first thing I want to do is I want to read our first clock blurb, and it talks about the minute hand being 5 inches, and the center is at 0, 0. So we think of this as our unit circle. The center is 0, 0, but a unit circle has a radius of 1. Because the unit circle radius is 1, and this clock has a radius of 5, we want to think of this clock as scaled by 5. So our x and y coordinates each need to be multiplied by 5 or scaled by 5. The first thing that I want to do is I want to approximate where 45 minutes after the hour would be. So the minute hand for 45 minutes is going to be at the 9. If we compare this to a unit circle, our coordinate angle measure would be pi. So our radian measure is pi here. If we look down at our chart, our estimated values at pi are -1, 0. Now this is for our unit circle. So we take this and we scale it up by 5. -1 times 5 is -5. 0 times 5 is 0. So this is a possible solution here. Another possible solution is to remember that on a unit circle, cosine is our horizontal values, and sine is our vertical values. So we could use sine and cosine as well. So another possible solution would be 5 times our scale, 5 times cosine of our angle pi, comma, 5 times sine of our angle pi. If you would simplify cosine of pi, you would get -1. And if you would simplify sine of pi, you would get 0. So these are the same answer, but you could answer either version on this part. Same idea for part B. 10 minutes past the hour. Would be here at the 2. On a unit circle, that's approximately pi over 6. On a unit circle, pi over 6 has the approximate values of 0.87 and 0.5. Again, we need to scale this up by 5. 0.87 times 5 is about 4.3. 0.5 times 5 is 2.5. You could also write this using sine and cosine. Again, use your scale factor, 5 times cosine of our angle pi over 6. That's our horizontal coordinate, and our vertical coordinate would be 5 times sine, again, our angle measure, pi over 6. So either of those answers, again, would be correct. For part C, we are at 40 minutes after the hour. 40 minutes after the hour is at the 8. If we look at our unit circle, this would be about 7 pi over 6. And again, you'll notice that this is the opposite of pi over 6. So there's actually multiple ways on this to write 40 minutes after the hour. So you can use 7 pi over 6, or you can do the opposite of pi over 6, which is what we used up above for part B. If we do 7 pi over 6, again, we do 5 cosine 7 pi over 6, comma 5 sine 7 pi over 6. You could also write opposite 5 cosine and then use pi over 6, or opposite of 5 sine pi over 6, because they have the same coordinates, just both are negative. You could also approximate. So again, we use this chart. We'll notice here that 7 pi over 6 is negative 0.87, negative 0.5, which is just the opposite of pi over 6. So if we use our unit circle, negative 0.87, negative 0.5, and you scale it up by 5, you get negative 4.3, negative 2.5. So any of these ways of solving this are correct. Moving on to the second part here, we have out another clock, but now the radius, the length is 15 inches. So now we're scaling by 15. You have two options here. You could do your unit circle times 15, or you could use the answers in the previous problem, because that was 5, and we know 5 times 3 is 15, so you could use your previous and you could times by 3. Either one's correct. You're going to get relatively the same answer. There might be a little bit of an estimation issue, but it'll be close enough. You can use the same, it's going to be the same radian measures for each of these. It's 45 minutes, which again was pi, 10 minutes, which is pi over 6, and 40 minutes, which is 7 pi over 6, or you could use the opposite of pi over 6 answers, right? Again, very, very similar answers here. So instead of 5 times everything, now it's just going to be 15 times everything. So negative 15 comma 0, or you could have 15 cosine pi comma 15 sine pi. And for 10 minutes, to be approximately 13.05 comma 7.5. When you take 0.87 times 15 and 0.5 times 15, or your answer 4.3 times 3, which is like 12.9, and 2.5 times 3, you get 7.5. So either of those is fine. Okay. And then the next one, again, you could use 7 pi over 6. You could do the opposite of pi over 6. There's a lot of different possible answers on this one. But they're all going to be correct, no matter what you pick. As your answer path. Okay, the last portion here is just a little bit different. It's kind of doing some things in reverse. So now they're giving you your original center and then the approximate X and Y of where your minute hand lands. So we need to figure out the length of the minute hand. So there's two ways to kind of think about this problem. The first way is if you think about the minute hand, we know it's in the positive area, so there it is. There's my center, 0, 0. We know we have a horizontal coordinate, so we go over 7.5 and we go up 7.5. So we could use the Pythagorean theorem, because this is a right triangle, to find our hypotenuse. Pythagorean theorem says a squared plus b squared equals c squared. So 7.5 squared plus 7.5 squared equals our hypotenuse squared, or c squared. 7.5 squared plus 7.5 squared is 112.5. And if we square root that to find our solution, we get a hypotenuse of approximately 10.6. So our minute hand length is 10.6 inches. Okay, that's one way. Another way is to go back to thinking about the unit circle. So the only place in the unit circle where the answers are the exact same, they're equal, is at pi over 4, right here. They're both equal and positive. I should clarify that. Both equal and positive. So pi over 4 is about 0.7, 0.7. But we're at 7.5, comma, 7.5. So it's been scaled. By how much has it been scaled? Because we know the unit circle minute hand is 1, right? The unit circle radius is 1, so the minute hand will be scaled up from that as well. So if we can figure out the scaling, we can do 1 times that number, and that'll give us the minute hand length. So to find our scaling, if you do 7.5 divided by 0.7, it gives us a scale factor of about 10.7. And then our minute hand would be 10.7 inches. So that's another way to go about this problem. And that is it.